Hello and welcome to another video in my lecture series entitled Mold Design. In the previous video, we had discussed the impact of light weighing the product. In this particular video, we are going to focus on the certain parameters which are essential while selecting a screw. So without wasting any time, let's get started. So as you can see, a screw design is something which varies as far as the material to be plasticized is concerned. So, selecting the right screw for an injection molding machine is extremely important. Why? Because it directly affects the plasticizing quality. One. Second is cycle time. Third is part quality. Fourth is energy consumption. And last is screw life. So, there are different factors on which the correct screw design or correct screw selection depends, right? First is your material. So now we have different polymers all across the spectrum, and each of them behaves very differently during melting. So when it comes to engineering plastics, they require a more specialized screw with a specialized design, right? And when it comes to polymer types like PP, HDPE, or if it's a filled or an unfilled polymer, for example, a glass fiber filled for polymer, or a mineral filled or filled polymer, or a flame retardant polymer. And it also depends how sensitive is the material in with respect to heat, what is the abrasiveness, how abrasive is the material, and lastly, how sensitive is the material to moisture. So, for example, if we have an abrasive material like glass filled nylon or mineral filled nylon, so we need a wear resistant screw. And for heat sensitive materials like PVC or PET, polyvinyl chloride or polyethylene terephthalate, we require low shear designs because more the shear, more will be the heat generated, and this can lead to plastic degradation. For polyolefins like polypropylene or high density polyethylene, we generally prefer the use of general purpose screws. So, what is the crux when we come to selecting a material or selecting a screw for a specific material? So, if we design a screw for PP, that does not necessarily mean it may perform equally well for nylon or PET. Rather, it can perform poorly for nylon or PET. Second thing is that the screw L is to D ratio, the length to diameter ratio, is something which distinguishes one screw from the other. And why it's important it is because higher the ratio, higher will be the kind of force, or higher will be the melting quality and homogeneity. So, for example, if we have 18 is to 10 to 20 is to 10 L by D ratio, that is more or less specifically suited or tailor-made for general molding purposes. Going toward the slightly higher side, anywhere ranging between 22 is to 1 to 24 is to 1, we certainly get better mixing and melting. And for engineering plastics which need high mixing needs, right, which have high mixing needs with high mixing speeds, the L is to D ratio is generally more than 24 is to 1. So all in all, higher L is to D ratio would certainly mean better melting and homogeneity. But then if it's too high, that would mean high heat generation that could lead to material degradation. So a balance needs to be sought. Next is your compression ratio. You can see my cursor here, the compression ratio, what exactly it is. So these flights which you can see, these have more depth, or they are protruding more from the base of the screw, protruding out more from the base of the screw rather than the flights here. This is basically your feeding zone, and this is your metering zone. So why the compression ratio is important is because, first of all, compression ratio is the ratio of flight depth at feeding zone to the flight depth at metering zone. So it's basically feed depth divided by metering depth. So a compression ratio anywhere between 2 to 2.5 is suitable for heat sensitive materials. And again, as we go towards higher side, anywhere ranging between 2.5 to 3, that is the general purpose screw, and some plastics which are crystalline plastics for polypropylene or polyethylene, it can be as high as 3 is to 1 to 4 is to 1, right? So what exactly does compression ratio do, right? So it basically controls your melt quality, it controls how air is removed, so much so that there is no moisture, and then shear heating, because higher the depth, higher will be the shear, because more will be the friction as the plastic would get less space to really move, right? And if for some reason the compression ratio is not in the correct range, it can lead to unmelted granules, right? So that is certainly a big drawback of this. Next is your screw design. So how the screw is designed, as I already told you, there are three zones. The feed zone, which conveys the pellets or move them forward. Next is your compression zone, which is also known as transition zone, which where melting primarily occurs. Last is your metering zone, where homogenization takes place. So it depends on different applications. For example, uh, some applications may need general purpose screw, some may need barrier screw, or some may need mixing screw. And then we also have low shear screw. So, for example, if we were to mold a thin wall crate, so that would mean mixing screw, right? Because it improves color dispersion. And of course, for engineering plastics, barrier screw would be required because it improves melt uniformity. Next is the screw diameter, which is again dependent upon the short size, what is the grams of polystyrene produced in one shot, what is the machine capacity or machine throughput, what is the part weight. So we had also discussed this previously in one of our previous videos, that short size should be 30 to 70% of the barrel capacity. So if the short size is something which is not within the range, that can lead to some serious consequences. For example, if the screw is too large, right, that means that the material which is being melted is too much to be controlled. And if it's too small, that means the recovery time is large, because it would take more time for the plastic to melt. So that would mean that the mold has to stay open for larger for a somewhat larger time, right? Then it's your screw material, right? What kind of material we use while manufacturing a screw. For example, if we use a nitrided screw, then it is suitable for molding standard materials. When it comes to bimetallic barrel, then so abrasive fillers can be used for molding because of high wear resistance. Then there is another type of coating by the name of HVOF coating, which is your high velocity oxy-fuel coating that is specifically meant for glass fiber materials. And then for engineering plastics, we prefer screw made in tool steel. So, for example, if we talk about PA6 or nylon with glass fiber or calcium filled polypropylene or polymers or plastics with mass batch with flame retardants. So we usually prefer a screw which is wear resistant as well as corrosion resistant. So this is how your basic selection of screw is controlled, and we basically have to kind of think of these parameters which contribute to the selection of a reciprocating screw. And whenever we are doing so, we have to seek the advice of the plastic material supplier, the raw material supplier, and we also should talk with the machine designer or the machine provider or with a specialist who has experience in designing a screw or designing a screw specifically meant for a specific material. And there are many companies which solely manufacture the screw, right? And so you can get many aftermarket brands which sell these screws, right, to the molder. And again, when you are selecting the screw or submitting the RFQ to them, you need to specify the requirements, what kind of screw exactly you want. And it can be a standard screw or a customized screw, depending upon the requirement. And then that can certainly be delivered. So this is something which we need to talk about here in this video as far as screw selection is concerned. I really appreciate you guys listening to this lecture. Thank you for watching this lecture, and I'll see you in the other lecture.